In this video, we're going to look at implicit differentiation again. However, change of variables here. We have, in the first example, derivative of y with respect to t. Okay. T typically means time, and that's why I did a word problem next. We'll do that one second, number 39, in which we're going to have a change of time. So this first one is just to kind of get the idea, how does this work, mathematically? How does it work in calculus to find the derivative of some function y with respect to time? So just like before, where we do d over dx, we're doing derivative with respect to x, right? Well, we're doing derivative with respect to time now of the entire equation, both sides, left and right, everything. Now, as before, do your derivative, pretend it's all the same variable. This says with respect to t, but this is an x, doesn't matter. X, the derivative of x to the fourth is 4x to the third, right? Bring the 4 down, subtract 1. Now, with respect to time, though, and we have an x, what we do, dx dt. Again, I wasn't going to go into the specifics of how and why. What it comes down to is chain rule. Okay, this is saying we have a variable time. I don't know how time is related to x. So really what this is saying is do the derivative of this inner function x. Okay, plain and simple. Now, again, let's keep it easy. It doesn't match, you put dx dt. In the next one, it's still 4y to the third, but I have y, it wants with respect to t, dy dt. Okay? The denominator, the dt, always stays, it's with respect to that variable. The numerator, if it was an x, it's an x. If it's a y, it's a y. If we had a z, we'd have dz dt. On the right, it's a constant, 0. Yes, we could even do d dt, but, derivative of, or 0 times anything is still 0, so no point. Now, back to the problem. Find dy dt. I'm solving for this. Remember, if it helps, pretend this is another variable. Pretend it's like a z or something, right? Solve for z. So I need to subtract this whole thing to the other side. Negative 4x to the third dx dt. And now I have this 4y to the third multiplied by this dy dt, or z, whatever you want to do. Divide the 4y to the third out. Okay, as ugly as this is your answer, with the exception of simplifying, right? Reducing those 4's. Dy dt is negative x to the third over y to the third dx dt. In a word problem, what would probably happen is they'd give us some sort of x, some sort of y, and this rate of change, and that's what's going to happen. That's what we're going to look at in this next example. All right, I didn't write the whole thing. I think my little bullet points gets the gist of what the problem is saying. We have this demand equation here. Okay, that's given, and what it stands for, the P is the price, and that's in dollars. Okay, the cells is X, and that's in thousands of cells, so whatever they're selling, right, they're selling thousands of them. The question is, determine the rate at which cells are changing at a time when X equals 50, P equals 10, and the price is falling 50 cents per week. Let's come into this thinking like I have no idea what to do. All right, let's just look at what they give us and what these variables tell us. We want a rate. What do we know about rate? We know rate means derivative, right? Rate means slope, which in calculus we call it a derivative. The cells are changing. All right, so it's some sort of rate, right? And all rates, like think miles to gallon, right? Miles per gallon, or any rate, right? Miles per hour, or common ones that we use quite a bit. So I know a rate involves 2 units. The cells is x. right? And I probably should have put it, but it did say that determine the rate at a time which sells. So there was like at a time here. Oh well. Kind of makes sense because all these rates are in with respect to time. Okay, so cells is x with respect to time, right? Like our cells would change as time moves. It's not like backwards from there. It's not like our time is going to change based on cells, right? That doesn't really make sense. Time might freeze if you don't sell anything, no. So dx dt. Another common thing is dt is almost always in a word problem you're doing with respect to time. Okay, time moves, things happen. So determine this. This is what we're trying to find, right? Find dx dt. It gives us this x. It gives us this p. And then last, it tells us this thing, the price is falling 50 cents per week. Notice that's a rate, right? It's falling 50 cents per week. Therefore, this is a derivative because it's a rate. It involves price, right? Price over time. Well, if I have a change of price with respect to time, then that's dp over dt. The other thing here is it's falling. So we know it's also a negative. Okay, it's a negative 50 cents per week. Just knowing kind of what is involved in the problem is going to help a lot. In this course, in any Calc 1 course, but in particular this Business Calc 1 course, if you're not sure what to do, odds are you need to do derivative. Okay, so let me rewrite this problem. And now odds are in a word problem with derivative, it's with respect to time. I'm taking the derivative. I'm trying to find these rates of change with respect to time. Okay, determine the rate which cells at some time are changing. Okay. Now, I know x is 50, p is 10, and we have this information. Don't plug that in now, though, because then I'd have a constant and a constant and a constant, and I'd do derivative and I'd get 0 equals 0, and it's like, I don't know what to do with that. So before you make substitutions, do derivative. Derivative of 2p to the third, 6p squared. Now, variables don't match, right? dp dt. Derivative of x squared, 2x. Variables don't match, dx dt. Derivative of 4500, 0. Now, after you do derivative, go ahead and plug in everything we know. Okay, and then we'll kind of see from there what we need to do. X is 50, so I'm going to plug in 50 in for x. P is 10. Let's plug in that. We know dp dt, right, was negative 50 cents per week. So we have a negative 0.50 here. I'm going to write the rest in blue, just show you like all the variables that we had plugged in. Okay, I plugged in this x, I plugged in dp dt, I plugged in that p. Right, now we just have some algebra, some arithmetic, right? 10 squared is 100 times 6 is 600 multiplied by negative 0.5, which is half, right? So negative 300. 2 times 50 is 100 dx dt. Solving for this, add the 300, and then we could see once we divide the 100, dx dt is 3. So what does that mean? Determine the rate which cells are changing. So the rate at which cells are changing is 3. Okay, but remember x is in thousands. So cells are changing, well, and it's positive, we'll say cells are increasing, right? It's not just changing, it's increasing by 3,000 every week. That's a rate, dx dt. The cells, change of cells with respect to time.